Hi, my name is Jörg, and this is Michael, the developer of Vna tools. Both of us are working in the RF and microwave lab at METAS, the Swiss Federal Institute of Metrology. In this tutorial, we would like to demonstrate the interaction between our Vna metrology software and the vector network analyzer, and how a typical measurement process looks like if we use the rigorous uncertainty evaluation concept. Compared to the old and outdated ripple assessment method, the new concept is based on the evaluation of a measurement model and reflects the entire measurement process, the Vna calibration and the Vna error correction. Basic influences are characterized and associated measurement uncertainties are propagated through a full measurement model to the end result. In this example here, we would like to show you an SOLT calibration using 2.92 mm connector family and show you some verification measurements. The following steps describe the typical use of Vna tools. First step, create a new measurement project in the navigation bar. Second step, define the Vna settings in the measurement journal. Third step, collect all raw measurement and protocol the measurement process in the measurement journal. Fourth step, configure a Vna calibration and compute the error terms in the tabular page called calibration config. Fifth step, set up the configuration of the error correction and error correct all raw measurement data. Sixth step, visualize the error corrected data in the Data Explorer window. And finally, the seventh step, compare verification standards by using the verification calculation feature of Vna tools. This will calculate the complex difference and the normalized error based on the reference data.
In the first step, we create a new project in the navigation bar of Vna tools. For that, we click here on New Project. And as name, we choose here Tutorial 01. As Vna device, we choose ZNA 50 GHz. As cable, 2.4 mm to 2.4 mm. And as test port connector, we choose 292. When we click on OK, the new project will be created. As a second step, we set up the Vna. For that, we switch here to the measurement journal tabular page and click on Add Vna settings. Here, we preset first the Vna, and then we set the start frequency to 100 MHz, the stop frequency to 45 GHz, we choose 450 points, an IF bandwidth of 100 Hz, and the test port power of -10 dBm is fine for us, so we can click on OK here. In the third step, we collect all raw measurement data of our devices under test and calibration standards, and we protocol this in the measurement journal. As a first component, we measure a female open at port 1. For that, we have to move the cable at port 1 to its initial position. That's why I check here this cable movement box. And we have to do a new connection on port 1. Once the component is connected, we trigger the Vna to measure S11 and wait until the sweep is complete and read back the raw data. I do that by clicking here on measurement S11. I save this raw data under measurements 01, cal standards, open female 101.034.01 and click on save, and then we connect the next component, a female short. Now I didn't move the cable, so I can uncheck this cable movement checkbox here, but I had to do a new connection. Again, I click here on measurement S11 once it's connected. And I'm gonna save this under measurements 01 cal standards short female 101.025.01. And then I connect the female load to test port 1. And I save this under measurements 01 cal standards load female 101.045 and the first measurement. And I measure another female load at port 1. And I save this on the measurements 01 cal standards load female G86901. And now I've measured all my one-port components at port 1, so all my female components. So now I will measure the male components at port 2. For that, again, I have to do this initial cable movement for port 2 and the new connection. And I will connect the male open to test port 2. And now I will measure S22. And I'm gonna save this on the measurements 01 cal standards open male 100.998.01. And the next component will be a male short at port 2. And again, we do not move the cable at port 2, so I can uncheck this one, but we have to do a new connection on port 2. And once the short is connected, I will trigger the VNA. So now I can measure S22. And save this on the measurements 01 cal standards short male 101.007.01. The next component will be a male load at port 2. I will measure again S22. And I can save this measurement under measurements 01, cal standards, load, mail 101017, the first measurement. And I have another mail load which I want to measure at port 2. I'm gonna save this one on the measurements 01, cal standards, load, mail, G88001. And now I've measured all my one-port components. The next thing I want to do is a true connection between port 1 and 2. Therefore, I have to move the cable at port 2, and I have to do a new connection at port 1 and 2. Okay. Now I want to measure all 4 S parameters of this true connection and the switch terms between port 1 and 2. Therefore, I click here. Again, this will trigger my VNA device and wait until the sweep is complete and then read back the raw data. And I'm gonna save this on the measurements 01, cal standards, true 01. The next component which I want to measure is a 20 dB attenuator. Therefore, I have to move again the cable at port 2 side and I have to do a new connection on both ports. Okay, now this attenuator is connected and I can start the measurement by clicking here on measure all 4 S parameters of this attenuator. I'm going to save the raw data of this attenuator under measurements, or 1, devices under tests, then at 20 dB female male, the serial number, and the first measurement. In a fourth step, we want to configure a VNA calibration and compute the VNA error terms. For that, we go to the calibration config tabular page. Here, we click on New Config. We choose as calibration type SOLT between port 1 and 2, and we click on OK. This will generate us here this assignment table. The first 3 lines are the reflection standards at port 1. The next 3 lines are the reflection standards at port 2. And this line here is the transmission standard between port 1 and 2. So we begin with the first reflection standard at port 1. Here we choose as raw measurement measurements 01, cal standards, open, female, and we assign the definition for that standard. We choose 292 opens, female open, and this definition here. Then we choose the next standard. This was a female short. Here we could either click on the button or on the little arrow. Now I click on the button. This will opens me this dialog where I can select measurements 01, cal standards, short, female, and as definition I select 292 shorts, female, female, standard. Then load. This time I click here on the little arrow. I choose my female load. I choose this one here. And I select the definition for this female load. Now I've assigned all my female components at port 1. Now I have to assign as well definitions to the raw data for the male components at port 2. So my male open, male definition of this open, 292, open, male, then the short, male, the definition of this short, and the male load. Now I've assigned all my one-port components, and now I have my transmission standards where I measure the true connection between port 1 and 2. And this is an ideal true 50 ohm. Then, once I've assigned everything, I'm going to save this assignment table or configuration by clicking here on Save Config. And I choose as name SOLT01. And I click on Save. The next thing is I want to compute my calibration error terms. For that, I click here on Start. This will load me all raw data and all definitions of my calibration standards, and then it will perform the calibration. Now my calibration error terms are computed, and I want to apply them to all my raw data. I do that in a fifth step, and I go here to a tabular page called Error Correction, and I can create a new error correction configuration. I want to use journal 01, and as calibration path I choose my computed calibration error terms as SOLT01 from the previous step, and I want to apply those error terms to all raw measurements, which I did. Those are in this folder measurements 01, and the result should be written to SOLT01 out. He proposed me a name for this configuration called SOLT01 core config, and I can save this configuration by clicking here on Save Config. When I click on Start, he will perform the error correction for each calibration standard and device on the test. Now he loads the calibration error terms SOLT01, and then he will load all the different standards and error corrects them and saves them. This will take some time. You can see the progress here in the progress bar. Okay, now he has done that. And in a sixth step, I want to visualize some results. For that, I can go here to the tabular page called Data Explorer. Here, I see folders, and measurements 01 are my raw data, SOLT 01 out are my error corrected data. And if I expand that SOLT 01 and devices under test, I can find my 20 dB attenuator. Or if I expand my cal standards, I see all my one-port components and the two. And if I click on one file here, I get directly a graphical representation of that file on the right. This takes some time to load. And I can say here, okay, it's an attenuator. I want to see the transmission in dB, the reflection in linear. I can choose here Macklin log, which means the transmission here is in dB and the reflection is in linear. And I can show as well the uncertainties. And this shows me the uncertainty region. Or I can just show the magnitude and so on. This is a graphical representation of my data. I can go as well to table and do here the same. So I can say I want to see only the magnitude. I want to see it in transmission in dB. And I can show as well here the uncertainty of it. Okay. In a seventh step, we want to compare some verification components, the error-corrected data of them, to some reference data. Therefore, we switch to the Verification tab. Here, we create a new configuration by clicking on New Config. As you remember, we measured 4 loads, but we only used 2 of them in the calibration configuration. So the 2 ones which weren't in the calibration configuration, I want to use as verification standard. So the first one was this female load here. And I assign its definition. Then the next one is the male load at port 2, which wasn't used during calibration. I choose here the error corrected data, cal standards, and the male load. And I assign the definition for that male load. Once I have this verification configuration, I can save it by click here on Save Config. I save this configuration under SOLT01 with the extension verconfig for verification configuration files. And I click on Save and it's saved. If I click on Start, he will compute me the normalized error. So now he will load the error-corrected data of the female load and its definition or reference data, and then he will subtract that and compute me the normalized error. If I want to have more details, I can double-click on the normalized error, and a dialog pops up. In the top of this dialog, I see the difference of the error-corrected measurement data and the reference data. In a perfect example, I would have here 0 difference. But with real measurements, I have some measurement errors. I see here a difference, which is not 0. But as long as the uncertainties covers this 0 region here, the normalized error is smaller than 1. If it's not covered, the normalized error is larger than 1 and we are not okay.